Welcome everyone. In today's video we're going to be going over the most popular question on LeetCode, LeetCode number 1, two-sum. So let's get into it. In the top left corner we have the prompt from LeetCode, where given an array of integers nums and an integer target, return indices of the two numbers such that they add up to the target. So basically what we're going to be given in our function is an array like this one right here and a target like this, which in this case is 12. So basically what they are wanting is, in this array right here, are there two numbers that add up to the target 12? And in this case there are, and that is 5 and 7. So what they're wanting are the indices of those values in array format. So we'll say output, and then we'll do an array, and the indices of 5 and 7 are 2, 4, 5, and 3, 4, 7. And this is what they want outputted. Now, how do we actually translate this into a solution? Well, the first solution and the most intuitive, which is probably the solution that you will come up with when trying to do this on your own, is starting at the first index, which in this case is 3, check the rest of the array right here to see if 3 plus one of these future numbers equals the target of 12. So we'll say our first index right here is 0, which the value is 3, and then we will scan the rest of the array after 3 to see if 3 plus one of the future numbers equals 12. So let's do that. We're at 3, and then we'll go to 1. We'll say 3 plus 1 equals 4, which does not equal 12. Then we'll move to 5, and we'll say 3 plus 5 equals 8, which does not equal 12. Then we'll move to 7, and we'll say 3 plus 7 equals 10, which does not equal 12. Now, since 3 did not add up with anything else in the array to equal 12, the target, we just increment our first index, and let me delete all of this. And we'll increment the index to 1 with the value of 1. And now, starting from 1, we will check the rest of the array on to see if 1 plus any of those values equals 12. So we'll go 1 plus 5 equals 6, which does not equal 12. Now we'll move on to 7, and we'll say 1 plus 7 equals 8, which does not equal 12. So now we're at the same thing we did with 3, and now we will increment our index to 5 and check if future values add up to 12. So 5 plus 7 equals 12, which does in fact equal 12. So we found our two values right here, 5 and 7, and our output would just be those indexes, which are 2 and 3. All right, so this is the kind of brute force solution. Each time you reach a value, you have to check the rest of the array. So for each value in the array, you're checking the rest of the array. So if you have in values in the array, you are checking another in values, which is in by in, which gives us a time complexity of O of n squared. And this is accomplished with nested for loops. If you're doing a problem and your solution is O of n squared time complexity, generally you can probably get that down. As far as space complexity, we are sitting at O of 1, which is constant space complexity. This is because we did not use any extra memory to solve this problem. So right now we have the not optimal solution, the brute force solution, as some would say. How do we get that down? Well, let's grab this array. So we can actually go through this array in one sweep. And we can do that because let's say we are at 1. We can say to ourselves, what number do we have to add to 1 to get to 12? Well, that is just 12 minus 1, which equals 11. And then we can store all the previous values we visited in a data structure that I'll talk about in a second and ask, have we seen 11 before? And if we have, we know that the two numbers that we want to get to the target are in the array, and we can return their indexes. Now, what data structure am I talking about where we can store key value pairs and retrieve them in constant time? If you don't already know, it is a hash map. And if you don't know what a hash map is, basically you store key value pairs in there and you can retrieve the key value pairs in constant time. I'm not going to go over specifically how that happens. I'll do that in another video. But just know that you can store key value pairs in a hash map and retrieve them in constant time. So we have our little hash map over here. Now let's start at 3, the first index and the first value. And now let's ask ourselves, what number do we have to add to 3 in order to get 12, the target? Well, that's just 12 minus 3, which is 9. And then we ask ourselves, have we seen this 9 before in the array? Or is 9 in our hash map? And the answer is no. So what we do is add the current value, which is 3, to our array and map it to its index, which is 0. And we're mapping it to the index because we have to return the index at the end of this problem. And then what we do is erase all this, increment our index to the value of 1, and now we ask the same question again. What number do we need to add to 1 to get 12? And we'll go 12 minus 1 equals 11. Have we seen 11 before in the array, or is 11 in the hash map? The answer is no again. So we add 1 to the hash map with the value of its index, which is 1. So now we erase all that and we increment the index again to 5, and we say 12 minus 5 equals 7. Have we seen 7 before, or is 7 in the hash map? And the answer is no yet again. So we add the current value 5 and map it to its index of 2. And now we are at 7. And then we say, what number do we add to 7 to get 12? 12 minus 7 equals 5. Now, have we seen 5 before, or is 5 in the hash map? And the answer this time is yes, it is. Woohoo! So all we have to do is get our output and return the index that returns when we put 5 into our hash map, which is 2, and 3 for the current value. And that is the same output we got for the last solution. However, this time we only went through the array one time. And since we're only going through in values and hash maps have constant time lookup, our time complexity this time is just O of n linear time complexity, which is a very good time complexity and is the optimal solution for this problem. Now, as far as space complexity goes, we did add some extra space which is O of n, because we are at worst case scenario storing n values in our hash map. However, generally, when you want to decrease the time complexity, you have to increase the space complexity. So in our case, space complexity went up and time complexity went down. But that is okay because usually time is more important than space. So now how do we get all this jumbled mess into some beautiful code? Well, let's hop over to LeetCode and see how. Alright guys, we're in LeetCode now, so let's write the code. So to start off, we're going to make our hash map. I'll just call it a hash map. And in Python, it's just a dictionary. And then we will do a for loop, for I in range of the length of the nums list that we're given. And then we need to make a variable for the number we're looking for in the hash map, the previous number we might have visited, which is, we'll call it num to find equals target minus the current value that we're in the loop. So nums I. And then we need to check if the value, the number we're trying to find that fits with the current value is actually in our hash map. So we'll say if num to find in hash map. And then if that is true, then we found our two numbers. It's just the current value we are in the loop and the value that returns when you put num to find into the hash map. So we'll just return, and they want this in an array, hash map num to find. This is just returning the index of the num to find, and then we'll just return I. Okay, and then else, if it isn't in the hash map, we need to add the current value to the hash map. So we'll say hash map nums I, which is the value, just equals I, which is the index. Now everything should work. Let's go ahead and run it. Alright, it looks like it got accepted, so let's submit. And boom, it was accepted. And we beat 99% of users using Python 3, which is pretty good. Alright guys, that's it. If you want more videos like this or more videos explaining data structures and algorithms, go ahead and subscribe and give this video a like so that I know that this is what you're wanting. Alright guys, see you in the next one.